Okay, today we're going to be looking at 1-4, which is measuring angles. So first of all, we need to know what an angle is. An angle is formed by two rays. Okay, and those two rays share an endpoint. So any two rays that share an endpoint is an angle. So for instance, you can see that we have an angle over here. It is formed by two rays. Those rays that it is formed by are called its sides. Okay, so for instance, in ours, the sides of this angle would be ray AB and then ray AC. Okay, remember with a ray, the endpoint goes at the beginning. And then the vertex of that angle is its endpoint. Okay, so for instance, in our angle, the vertex is point A. All right, naming an angle. There are a few different ways that we can name an angle. We're going to look at three today. The first one is by its vertex. So for instance, we could call this angle A. All right, when you are naming an angle by its vertex, be sure that it is the only angle that has that vertex. So here, that is the only angle that has vertex A. So I can name it A. But if I were to do that and form another angle, I could not call that one angle A because there's more than one. All right? So if that happens, I have to use the second option, which is naming it by three letters. When you name it by three letters or 3 points on that angle, the vertex goes in the middle. So A is the vertex of our angle, so it has to be in the middle, and then B and C can go on either side. So we can either say angle BAC or angle CAB. And then the last way to name this angle is by a number. So I can also call this angle 1. All right? And then also today it's important that you know the interior of an angle is contained by the two rays. The exterior is outside of the two rays. So we'll be looking at that a little bit too. All right, now types of angles. There are 4 different types we're going to look at in this section. The first one is acute. An acute angle has a measure that's greater than 0, but it's less than 90. It's a cute little angle. It's small. Then we have a right angle. A right angle is exactly 90 degrees. And with notation, we'll have a little square to tell you that it's right. Then we have an obtuse angle. An obtuse angle has a measure that's greater than 90, but it's less than 180 degrees. So it will never hit 180. The biggest it will be is 179. Okay? And then the last one we have is a straight angle. A straight angle is an angle that is exactly 180 degrees. A straight angle is also a line. Okay? So any line forms a straight angle. All right, so let's look at number 2. We're going to look at some measures of angles and see if we can determine those. So when we're finding the measure of an angle, we would denote that M and then the angle name. Okay, that little m means measure. All right, so if we want to find the measure of LKN, we can use a protractor to do that. We may look at that a little tomorrow in class. So here's angle LKN. All right, that angle there. Its measure, if you look at L, it ends on 130. Okay, it goes from 0 to 130. Use those bottom numbers. All right, so the measure of LKN is 130 degrees. Okay, let's look at the measure of NKM. All right, the measure of NKM here, if we look at that, let's do this one in blue. So NKM is this angle. Oh, it's a cute little angle. And again, using the bottom numbers, I can see that it is 50 degrees. All right, so this one is obtuse at the top. This one is acute. I want to show you one more thing with this really quickly. If I were to ask you for the measure of JKM, which is this angle here, I can't just look at the bottom numbers to get my measure. I'm going to have to do a little subtraction to get it. And for that, we'll do the same exact thing as we did with finding the length of a segment. We can subtract and then take the absolute values of those numbers. So if you look at this one, it begins at 50, so that's 50 minus, it ends at 90. And we want to make sure we take the absolute value. We can't have a negative measure. Okay, so this is just going to be 40 degrees. All right. Okay, the next thing we're going to look at is congruent angles. Congruent angles are angles that have the same measure. Okay, those are congruent angles. So for instance here, A and B have the same measure. Let's say that they're both 30 degrees. So if they're both 30 degrees, we know that their measures are the same. So the measure of angle A is equal to the measure of angle B. Therefore, we know that angle A is congruent to angle B. Okay? And this mark, just like we had marks for segments, means that they are congruent. As long as they have the same number of marks, they are congruent angles. So let's look at this example down here. We want to find the angle that's congruent to WBM. WBM is this angle. Notice it has one mark, so we're looking for another angle that has one mark. And if you look, you can see that one right here. This one has one mark. So we can say that angle WBM is congruent to angle, and there are several different ways that you can name this, but let's just name it BE, and we need one more point, A. Angle BEA. Notice the vertex BE has to be in the middle. All right, the last thing we're going to look at is the angle addition postulate. The angle addition postulate allows us to add small angles together to get measures of big angles, just like the segment addition postulate, okay? So we're going to look at number 4 now. It says that DEF is a straight angle. All right, stop there. As soon as you get a piece of information, go ahead and write it down or label your diagram and use it. All right, so we know DEF here, this blue angle is a straight angle, meaning its measure is 180. All right, so what we want to do is find out the measure of the smaller two angles. So we know that the measure of DEF is going to be equal to the measure of DEC plus the measure of CEF. So now we can replace it with what we know. We know that DEF is 180. We know that DEC is 11x minus 12. And we know that CEF is 2x plus 10. All right, so now it's just an algebra problem, so we can solve it. So 182 is equal to 11x plus 2x, which is 13x. I just skipped a step there. So x here is equal to 14. All right. So now I can plug x in to get the measure of each one of my smaller angles. So if I plug x in here, I get 11 times 14 minus 12. So we have that 11 times 14 is 154. So that's 154 minus 12, which is 142. Okay, so that angle is 142 degrees. So to find our other angle, we have two options. So we're going to find this one. I'll do it in green. We can either do 180 minus 142, so the whole entire angle minus the smaller one. So when we do that, we get 38 degrees. And then we could also just plug in x, which would give us the exact same thing, but if you want to see that, that's 2 times 14 plus 10, which is 28 plus 10, which is also 38. So you get the same answer doing it either way. I just wanted to show you that there are two options for that. All right, so that is it for 1.4. If you'll scroll over now and watch video 1.5.